All right, let's get started. So today we want to kind of wrap up our 115 content. Arraylist and hash map are the last two 115 topics that we'll talk about. So let's do this, and then Wednesday we can really start some 116. And of course we're going to talk about the two data structures, but there are quite a few, 116, well, not necessarily 116, but memory diagram topics. And as we go throughout this semester, I'm going to dive deeper into memory and expand on what we're seeing. Because so far I've just been showing you memory diagrams. I didn't really give much context to what they are. So let me add some of that context right now, and I'll add more as we go through the semester. So RAM. You have a couple of these chips inside your laptops right now. If you've ever built a desktop, built any computers, you've seen these things. If not, this lives in your machine. And whenever I talk about memory, I'm talking about RAM. When we do memory diagrams, we can name them RAM diagrams. It'd be the exact same thing. RAM stands for Random Access Memory. And these sticks are effectively just one giant array of values. And that is memory. So whenever your program runs or whenever you open up a Chrome tab or anything, we're using memory in these chips. This is where all of the memory for that program is stored. And then if we need long-term storage, if you need to save a file, if you need to write to a database or read from a database, then you're accessing your disk drive. We don't call that memory, we call that long-term storage or just disk space. But whenever we're talking about memory, we're talking about the RAM sticks. So one big array, and it is literally an array. It has indices for the values in it, except it has billions of indices. If you got 16 gigs of RAM, you have roughly 16 billion, more than 16 billion memory addresses where you can store a byte of information in RAM. When you start your program, you're going to ask the operating system, or more accurately, we're going to ask the JVM. The Java Virtual Machine is a program that runs Java programs. So whenever we run our Java program, we're actually running it on the JVM, and then the JVM talks to the operating system. But I'll say JVM and OS interchangeably. One of those, we're talking to the JVM, which talks to the OS. In general, programming languages will talk to the OS. For Java programs, we just have to go through the JVM. So for the concept, we're asking the OS for memory. So when we start our program, we're going to say, hey, I need some memory. I got some work to do. I got some variables to store. I'm going to be creating stack frames and everything. I need some space to be able to store this information. This is like the scratch space for the program. It's like its notepad where it can write things down where it's running. The operating system says, sure, here's your chunk of RAM that you can use for your program. It's going to give you a spot on this RAM stick, which is just for your program, and no other programs can touch it. The operating system will prevent any other program from accessing that memory, hopefully. Some security issues exist. And we can't go outside of that memory. This is our space for our program to run. And this is a sequential chunk of the RAM, So we get memory addresses 100 to 500 or whatever. Those wouldn't be the actual numbers. But we'll get one sequential chunk of that array. So we get a subarray of the array, and that's where we store our values, and that's what we call stack memory or stack space or just the stack or the program stack, whatever we say. If the word stack is in there, it's almost always what we're talking about until we actually talk about stack, the data structure in week 4. But that's our space to store our variables and put our stack frames. There's a last in, first out data structure. So I always like to think of a stack of papers. If I put a paper on top, that's the only paper that I can access, and it's the only paper I can remove, and then I have to work from the top of the stack, and I can add to the stack, I can remove from the stack, but I can only add and remove and access the top of the stack. So the stack is a stack of stack frames, and only the stack frame that's on the top of the stack is the active stack frame, and only variables within that stack frame are currently accessible to the program. And once that method call returns and that stack frame is destroyed, whatever stack frame is underneath it, that's now the active stack frame again. Now, we've only seen programs with 2 stack frames at a time. The main stack frame, which we don't denote in any special way in our memory diagrams, and then we'll have one method call at a time. to add one stack frame, and then when that returns, it returns access, it returns control back to the main stack frame. But we will eventually see examples where there's, starting I think Friday, will be our first one, where we have multiple stack frames on the stack simultaneously. Only the top one can be accessed, and once it returns, control goes back to the one underneath it. Or visually in our memory diagrams, we do draw these upside down, so visually the one on the bottom, but conceptually with the stack data structure is the one on the top of the stack. But in our memory diagrams, the lowest stack frame visually is that's not crossed out is going to be the active stack frame. And when we cross it out, control goes back to the next one that's not crossed out. The new topic today, heap space, and spoilers, array lists and hash maps are both going in the heap. This is our first use of heap space. Heap is different than the stack. The heap is more dynamic. So where the stack is one continuous block of memory, and we fill up each memory address that we have available to us with the next variable that we're going to put on the stack, and the next stack frame that we're going to put on the stack. Heap space is more dynamic. Heap space is when we go to the OS and we say, look, you gave me that stack space, that's cool and all, that was really nice of you and all that, but I need more. Like, I need something a little more flexible. This stack just ain't doing it for what I'm about to do. So we go to the OS and we say, we need some memory for this array list we're going to create. It's going to be our first use case of the heap. We say, hey, I need some more memory, and the operating system is going to give us a chunk of memory somewhere that's going to be the exact size that we asked for, the exact size to create our array list, and it's going to create that memory. It's going to allocate that memory somewhere in memory other than our stack. It could be anywhere in memory except part of our stack, because that's already allocated for our program. We can't encroach on that. That's fixed for the runtime of our program. But somewhere else in memory, it's going to give us a chunk of space and then give us a reference to that location. So it's going to give us the memory address of where we can find that spot in RAM, and then we use that reference to be able to access that space that was allocated for us in the heap. So heap space can be anywhere. We don't care where it is. We just care that we're able to access it through the references that we get from the operating system. So with that, let's talk about array lists. So here's array list in Java. Making a petition to start and end each class with tunes. That is the idea. That's the plan. Oh, yeah, you already got me. So array lists. So the idea, just very quickly. So my idea is to have it automatically start. It automatically stopped. It should automatically start at 2:48, and that's my cue to shut up and show you the lecture question, just to keep me from going over time. So array lists are similar to lists in Python, array in JavaScript. It's our sequential data structure, and everything in this data structure is indexed starting at 0. Just like you've seen in 115, I don't have to belabor that point. But this is our sequential data structure that we're going to use in Java. This is our first import statement. On Wednesday, I mentioned this. Everything you write in Java goes in a class. Then I added a couple exceptions. I said, well, except your package declaration. Well, except your import statements. But I never mentioned what an import statement was. I just kind of mentioned it and then moved on because we had so much to get through on the last 2 days and today, actually. But here's where we want to talk about import statements. There are certain types in Java, certain code, certain classes that you can just use. You don't have to import them. You just start using them. This includes all our primitive types, which is any type that starts with a lowercase letter. This includes strings. And this includes system. When we do system.out.println, we didn't have to import system. And in general, any code that belongs in the java.lang package. All of those classes in there can be used without importing, so you can look at that package, look at all the classes that are in there, and see everything that's auto-imported for you. Array lists and hash map are not in that package, so they need to be explicitly imported before you can use them. So for this, for an import statement, we need the fully qualified name of a class. What that means is you have to have the package name and the class name. So we're going to import ArrayList, which lives in the java.util package, meaning the Java package, which has a sub-package named util. And instead of slashes like a directory structure, we use dots in our package names. Java.util.arraylist inside Java/util, that directory, there's a file called arraylist.java, and that's where the arraylist class is defined. So if you look through the Java standard library, all the code that just comes along with Java, you can find the code for arraylist following that path. So we need to import that, and IntelliJ is usually good about imports. If you just start using arraylist, it'll either auto-import it for you, or if all of your Word array lists are in red and there's errors all over your program and it doesn't run, usually means you didn't import it. And if you either click or hover, I always forget, on it and click the red light bulb, the autocorrect feature in IntelliJ, one of the options will be import the thing. You click import, and then it'll import it for you. So you don't have to remember, okay, what package was ArrayList in? IntelliJ, let's just use the tools and cut down the memorization so we can focus on the concepts and focus on writing code. When we want to use an ArrayList, when we want to create a new ArrayList, we'll use the keyword new, which we'll see a lot throughout the semester. A lot of this we're going to go into more detail on week 3. Words like classes, object, constructor. But let's do just enough to get us through today. Let's talk about that much today. So new is going to create a new array list in this case. For array list, we have to have these angle brackets. These angle brackets are going to match what's in the angle brackets over here. If we leave this empty, this is a shortcut Java lets us do. If we leave this empty, it'll be assumed that's the same as the variable we're assigning it to. So this is the same as saying integer right here. We just don't have to say integer right here. But these do have to be there. If we put integer, that would be perfectly fine too. It would be more explicit, be more clear what we were doing. But my code on the slide would go out to here, and I just didn't like that. So. And then finally, an empty argument list. So when we use the keyword new, what we're doing is calling a special method called a constructor, which is going to create a new object based on that class. Now, that's a big loaded sentence. We'll talk about it a lot more next week. But for now, new does call a method. This method doesn't take any parameters. The ArrayList constructor doesn't take any parameters, but we still need our empty argument list, even if we're not passing anything to that method. So we are calling a method. We do have to have an argument list, even if it's empty. When we declare a variable, we always have to have the types of our variable. So we need a variable of type ArrayList. But if we just did ArrayList R1, technically that would work, but it's not what we want. It's not what we want to do. When we create a data structure, when we create an array list, we need to specify the type that's going to be stored in that array list. So we don't just create an array list, we're going to create an array list of something. Here we're creating an array list of integer, and we do that by putting a type parameter inside angle brackets. I guess a type argument in this case. We're going to specify what type this array list is going to store. So we say this is an array list of integers or an array list that stores integers. And this array list can only ever store integers for as long as it lives. So if this is an array list of integers, I can only add integers to this array list. I can't add a string to it. It's going to yell at us. This is something we took for granted in Python and JavaScript. We can mix types in our data structures. Not the case in a strongly typed language like Java. We can only store integers in this array list. If we create an array list of strings, we can only store strings in that array list. No other types. Now notice that I'm using capital I integer. We've never seen this type before. We've always used lowercase I int. And there is an important yet kind of subtle difference between the two. So whenever you use a type parameter, whenever you create an array list of a certain type, that type cannot be a primitive type. So all our types that start with lowercase letters are int, double, boolean, and kind of char. I just mentioned it kind of off the cuff a little bit. Those primitive types, we cannot create array lists of those types. Just can't do it. Not allowed. Java won't let us do it. But each of those primitive types have a corresponding class defined for them. So the integer class, capital I integer, is a class that's its whole purpose is just to store one integer value, just one int, but it is a class instead of a primitive, which are different, do behave slightly differently. Now, Java is usually really good about automatically converting between the two, called autoboxing. So you can, for the most part, use these interchangeably. So I have an array list of capital I integer, the class, but I have x, which is a lowercase I int. I have 10, which is an int literal, which will be a lowercase I int, not a capital I integer. Java won't automatically turn this into the capital I integer class or object. So this is a lowercase I int, and I'm adding it to an array list of integers. And that's perfectly fine. Java's going to be like, I got you. I know what you mean. So in most cases, Java's going to auto-convert between the two. We're always going to use the primitive types unless we have to use something else. So this is the first case where we have to use the class types. So I have to use capital I integer here. Other than that, we're always going to use the primitive types. But primitive types can't be type parameters, so we're stuck with capital I integer for this case. Be careful with this. If the homework asks you to write a method that returns an int and you return a capital I integer, there can be complications with the autograder. So if Autolab asks for, if the homework doc asks for one thing, make sure you're returning that specific thing, which is always going to be the primitive type unless otherwise specified. Unless we need it as like a type parameter for our purposes now. And for your code, if you mix them, it usually works fine. If you're running it, I shouldn't say on your code, but if you're running it in IntelliJ and compiling the whole project together, Java's usually going to be fine with that. But just the way that things are graded in Autolab, I'm compiling different parts of the submission separately. So I'll compile your tests, for example, and then compile my correct and incorrect solutions, and then jam the compiled code together. So I'm not compiling them together, which does change things. I realize I haven't introduced compilers yet, so that might not make sense. But just the way things are graded might cause complications. Not always, but sometimes it does. So just be cautious of that on your homeworks to follow the right type. Okay, so when we want to access values and add values to an array list, add is going to add that value at the end of the array list. You've seen this with push and append. It's the same thing. It's just called add for array lists in Java. So this is going to add the first iteration of the loop. This is going to add 10 at index 0, then 9 at index 1, then 8 at index 2, 7 at index 3, and then the loop ends. If we want to get a value at a specific index, we use .get, and then the index that we want to retrieve. So when x is 0, this is going to get the value stored at index 0. If you want to get the third element out of an array list, you call .get of 2, and it's going to return that third value. So very similar to what you've done before. Worth noting, you cannot use square brackets. You can't say rin of using this syntax, x, and then close square bracket. You can't use that syntax. It's not allowed. Can't use it for an array list. That syntax does not exist. Can't use it. Might be relevant at 248. Don't forget that one. You can't use that. You have to use .get. If you want to access an element at an index, you can't use your square brackets. For an array list, specifically. All right, any questions on the syntax for array lists in Java? Can we convert the class equivalents back to the primitive types for Autolab? Just so for your, the issues in Autolab that causes is in your method signatures. So if you have to write a method that takes an int, but instead you have that method take a capital I integer, just make sure you follow it there. If your local variables or pretty much anywhere else in your code, you mix and match and just use the two interchangeably all willy-nilly, that should be fine. But your parameters, your parameter types, and your return types of your method. So your method signatures have to be exact. because when I call your method, it can cause issues. It doesn't always. It might not even be a case for the way I'll set things up this semester. We might just not run into that issue, but I have seen that issue in the past. I've taught Java classes in the past, and it has caused issues. I forget off the top of my head what specifically happened, but just a heads up that there is something that can occur in your method signatures that can cause issues. And if it does come up this semester, there's a good chance for me to look into my autograder. Maybe I can fix that and have it not matter. Ideally, that would be the case. Any questions on arraylist syntax? Let's memory diagram this thing. All right, so memory diagrams, I know we've only done them for 2 days, but I think loops, method calls, variables, printing to the screen, I think a lot of that should start feeling a little bit old hat at this point. You've seen multiple examples of each of those things that we can focus on the new stuff each time we see these things. And we're going to do the new stuff right away. The very first line of the main method is creating an array list. By the way, if there are questions on any of that stuff, please ask. That's just my assumption. If that assumption is wrong, raise your hand, hit me up in the chat, and be like, wait, how are these loops working again? We had some good questions in the last lecture because these slides are going to pretty much skip over the loops. So if you weren't 100% sure what happened with the loop, just please ask. I'll happily explain it. But after a few loop examples, I assume that we're pretty good on them. But let me know if it's not. But let's get to the new thing. We're going to start using this heap. So whenever we see new, the keyword new, that's our cue that something's going on in the heap. So we see new array list. New means, hey, operating system, give me some space for an array list, and then call the constructor method. That's what we're doing here. So when we create a new array list, the operating system gives us some space somewhere in memory other than our stack. And then we set that space up to be an array list. We order our bytes. We use that space to be an array list. For our memory diagrams, we're going to specify that by that last lecture too. I got ahead of my slides right there. We're going to separate this into 2 columns, one for the indices and one for the values at those indices. So we're going to draw this. It just looks like a T right now. But this is going to be a column for our indices and a column for the values at those indices. And this is going to be located at a specific place in memory. We're going to denote that location using a memory address or a reference. And we're specifying these references using OX. We're going to start with OX and then some number that you just honestly just make up. OX means this is a hexadecimal value, but I'll avoid A through F just to make it a little less confusing. I'll make them look like decimal numbers in my slides. But OX means it's a hex value, which the memory addresses in your RAM, remember it's one giant array. The reference, the indices of that array are hex values. That's how we access specific bytes of memory, is specify the memory address of that value. Now, technically, in Java, we don't have access to the actual hex value, the actual memory address. I have to mention this because Matt gets upset about it, that I do this, that me and Paul do this with hex values. The JVM obfuscates this and doesn't actually give us access to the memory values. So just to appease Matt, I'll give this disclaimer, and then I'll go back to using memory values. We get some random values that kind of correspond to where we can find that value, but the JVM hides the actual memory addresses for us in Java. In general, programs have access to that memory. Like your C programs will have access to the actual memory addresses. So the concept applies with memory addresses, even though the JVM doesn't technically work like this. So there's my disclaimer to appease Matt. Dr. Hertz, a lot of you might have had him. But I'll appease him by saying that, because he gets really irritated. But he's just going to have to get irritated. And whenever we, and that's our memory address, that's where we can find this array list in memory, somewhere in the heap. We don't know where it is. We don't care where it is. For our memory, when we run our programs, we just get some space somewhere in RAM. We don't care where it is, but we get a reference. We get that memory address, which tells us, hey, here's where you can find that information. And that's what we care about, that reference. That reference says you can go to memory address 200 and find that array list that I gave you space for. Now, the value I mentioned that's just made up, as long as they're consistent, as long as this matches this, and we're even going to draw an arrow to make it very clear that this is a reference referring to this space in the heap. But that number can be made up. When I made this slide, I just said, I feel like using 200. When you draw your memory diagrams, you don't have a JVM sitting there allocating, in an operating system allocating memory and giving you memory addresses. So just make up a number as long as you're consistent for that array list, as long as whenever you have a reference to that array list, you use the same number. So I used 200 for this one. For your memory diagrams, or for Paul and I, we like to use 3-digit decimal numbers. Just, I don't know why, this is just what we both ended up doing. You can stick with that. If you want to use OX1, OX2, OX3, a lot of students do that on their memory diagrams. It's perfectly fine. If you want to use OX2FE3B as a memory address, go for it. Knock yourself out. As long as you're consistent between your references and what's being referred to. So we put the reference on the stack and then have it refer to the object that it's referring to. I think my next slide adds stuff. Okay. So R1, the variable here, it's of type array list of integers. It does not store an array list of integers. R1, the variable, does not store an array list. It stores a reference to an array list. Might seem like a subtle difference, but it's a very important difference. R1 only stores a reference to an array list. R1 stores a memory address, just one chunk of information. It's basically a roadmap of where in memory we can find that array list. And that's it. It doesn't store anything else. It just stores that address. Where can I find that array list? That's it. And then that address can be used. You can actually use those instructions and go find your array list in heap space. But it does not store an array list. Then we can start adding things to the array list. We call .add, and now we can see our two columns in action. They were just empty columns before, which might not have been super clear. But when we start adding, we're going to add values to the end of the array list. We have an empty array list, so the very first thing we add, we're adding 10. It's going to be at index 0. So index 0 stores the value 10. Jump through the whole list, cross out our for loop at the end, and we get 4 values added to our array list by going over to memory and adding those values to our array list. And very small note, but students have been asking a couple, so very, very minor, but I want to make sure I mention this in all 3 lectures. We do not cross out the last value of a for loop. We leave that uncrossed out and then move on. If you cross that out on your memory diagrams, I don't care. Paul doesn't care. The TAs don't care. We don't care. But just technically to be consistent, and I updated my slides from Friday, we don't cross out the last value. So just so I'm consistent in lecture. But if you cross it out, it will never be the difference between getting credit on a quiz or not. If it ever is, if you get feedback like, you crossed out the thing, no credit, no LO, come talk to me, we'll fix that. We'll get that fixed. I don't care about minute things like that. I was doing it wrong for a while. There wasn't even really a wrong. Me and Paul talked about it and said, okay, we got to pick one and just stick with it. So not crossing it out. When an array list is printed to the screen, it's going to be printed in this kind of JSON syntax, square brackets, comma separated values. I don't have much to say about that. It's just how they're printed to the screen. And then when we make an assignment, we're going to create another variable of type reference to an array list of integers called R2 and assign it the value of R1. Now, what's actually assigned when this assignment happens is kind of a big, deep question. If you're not looking at the memory diagram, it gets kind of tricky, and you run into this in 115. You kind of intuitively get an idea and a feel of what happens here. But now we want to draw the memory diagram, crack this open, and see what actually happens. So the short, easy answer when you have a memory diagram, what's assigned when you assign the value of one variable into another variable? Whatever's sitting right next to it as its value. We're not making a copy of an array list. We're not going to the heap and making another array list, copying over the same values and everything. We're not doing any of that. What's sitting next R1? What's sitting next to R1? OX200. Okay, we're assigning that to R2. What should be next to R2? OX200, period. Whatever's next to the variable in the value column, that's what's assigned. That's what that variable resolves to. This expression that's just R1, it resolves to whatever's sitting next to it on the stack. You don't follow the arrow and start messing around over in the heap. No, it's the reference. That's it. R1 just stores a reference. When you assign something the value of R1, it's just the reference. So R1 and R2, these variables both store a reference to the same array list. They both refer to the same array list. This is called assigned by reference. Only the reference is assigned, or if you want to nitpick, it's technically assigned by value, but the value being assigned as a reference. I will incorrectly call this assigned by reference. I apologize to anybody who gets upset by that. Some of you should be upset by that. In 220, your 220 instructor is going to straighten that out and talk about the subtle differences between assigned by reference and passed by reference, and assigned by value and passed by value, where the value is a reference, and then passed by value, the three different types of passing. I'm just going to call this assigned by reference, and I'll just live with the fact that I'm slightly technically wrong on that one. But it is assigned by value, but the value being assigned is a reference, so they both store the same reference. So when I print R2 to the screen, it's the same exact array. There's nothing different. I didn't get a new array list in memory. There's only one array list in this entire example, and I have two variables referring to that array list. So when I print R2, same thing as printing R1. Same with method calls. So I have a method that takes an array list of integers. Now I'm not packing up this whole array list. I'm taking all the integers and all the indices, stuffing it into this method called sum, and saying, sum, here's your array list of integers. Here's the thing you can work with. No, not doing any of that. I'm saying, here's a reference. Here's where you can find an array list of integers in memory. If you ever need to access that array list, just follow that address. That's the directions to the array list that I'm working with. Don't create a new array list. Don't copy the array list. We just have another variable with a reference referring to the same array list. That's it. That's all we're doing. So inside the stack frame, we have the parameter with a reference to the same array list. Out goes in there. And then whenever we want to access that array list, because we don't care about the reference. Nobody cares about a reference. Nobody says, oh, I have the array list OX200. Nobody's ever going to say that. And in your code, you never care what the reference is. The JVM won't even tell you what the actual memory address is for your objects. Even if you wanted to know, it's not even going to tell you. Can't even find that information. And who cares? We don't care. We just care that we're able to access that array list. And to access that array list or anything that's in the heap, to access it, given a reference, we use the dot operator. So rn, which is just a reference, OX200, which we really don't care about. In fact, we assigned it a random number. That's how little we care about this. We just gave it a random number and didn't even care what number we gave it. But we do care about the array list to which it refers. So we use the dot operator. The dot operator means, I know you're a reference and I don't care about you. Take me to the array list that you refer to. So rn dot size means rn resolves to OX200. Dot means let's follow the arrow and head over to the heap. And then size, we're going to call on the array list that we navigated to in the heap using that dot operator and the reference. So now we get to this array list and we say, hey, what's your size? And it says 4. And then that's what this resolves to. That's how this resolves to 4. by following the reference to the heap and then asking for its size, or calling the size method, rather, and getting the return value. Same thing with .get. rn dot get x is dot get x is 0, resolves to 10. Oops. So we're going to do out plus equals 10. So out goes from 0 to 10. So the dot operator, follow a reference to whatever it refers to in the heap. Run around the loop a couple times, we end up at 34. When we hit the end of the loop, remember that variable is destroyed. The code block is destroyed, so any variables declared in the code block, which is x in this case, is the only one, destroyed, and x is no longer in memory, can't access x anymore after the loop ends. But we did declare out outside of the code block for the loop, so out still exists, and then we can return out, get 34 into the main stack frame, print 34 to the screen, and then our program's over. There's quite a bit of moving pieces here. Anybody have questions on this one before we get to hash maps? Again, just a reminder, I have the Discord chat open, lecture channel. Anybody has questions? So we got quite a bit going on, method calls, code blocks with loops, the stack, and now heap memory as well, references. Any questions on any of this? There has to be questions out there. Y'all just don't want to ask. It's a lot of stuff that y'all learned. You didn't know what any of that stuff was last week. Unless, I think in Paul's lecture in 115, he did some memory diagram stuff. So if that's the case, then if you were in his section, you know some of it. But a lot of this memory diagram stuff is brand new. To most of you. There's got to be questions. Oh, we did get a Discord question. I'll walk away from my phone for 1 second. There's only a couple things. It's what? Oh. I've been watching it the whole time, and then the one, it doesn't matter. I'm happy to get something. Does size return the number of entries or the highest index? The number of entries. If I have 16 entries in an array list, would it return 16 or 15? It would return 16. So the highest index is 3. That size is going to return 4. And then when x is 4, so once we hit, when x is 3, let me back up to that. X is 3, we get the value at index 3, we get 7. Then we increment x up to 4, and then we check the conditional, and we get 4 less than 4, which is false. So we never execute the body of the loop when x equals 4. We break out of the loop and end it as soon as x equals 4. So x does end up equaling 4, but we never ran the body of the loop with x equals 4. How does the for loop know what to loop through? Is it because it's after declaring the array list? How does the for loop know what to loop through? Which for loop? I guess both of them are the same, but it's controlled by the 3 statements for the for loop. So for this one, x is going to be initialized to 0. We're going to check the conditional, which 0 less than 4 is going to be true. So we execute the body of the loop, and then increment x to 1. This is true. Execute, increment to 2. This is true. Execute, increment to 3. This is true. Execute, increment to 4. This is false. Skip over the body and return. So it knows based on the conditional, which is the middle expression in the declaration of the for loop. As long as that's true, we're going to keep looping. Once that's false, we stop. Can you go over when we use the dotted box? It's any code block other than a method definition. So when we call a method, we have a code block here, which creates a stack frame. Whenever we hit a pair of braces, that's not a method call, or I guess technically not a class definition either. But any code block that's not a method call, which is, for our purposes, it's going to be our conditionals, our if statements, and our loops. Those are going to be the 2 code blocks that we're going to see that use dashed boxes. Whenever we hit those, we create a dashed box. So for loops and if statements, and only if a variable is declared inside that code block. So here we have int x equals 0. The initialization statement of a for loop is kind of a special case. This is created within the scope of that code block for the for loop. So it's declared inside the dashed box. The big reason why this matters is once the loop ends, anything declared inside that code block, when we hit the closing brace, everything declared in that code block is erased from memory. So we don't have access to the variable x after the closing brace of the loop. This is something that you feel in 115. Every one of us has done this when we start learning programming. Right here, we'll try to return x, and it'll say variable not found. This is why, because it was declared within that code block. That code block ended, so any variables declared in that code block are erased from memory. Same with conditionals. You declare a variable inside an if statement, and then after the if statement, you try to return it. It's not going to work because that variable is destroyed when the code block ended. If we hit a code block, and we saw this with if statements and for our while loop, if we have a code block and no variables are declared inside the code block, we just don't bother writing the dash box. You can write it. You can draw an empty dash box. I'm not going to stop you, and you're not going to lose credit for that. But it's optional, and I'm going to choose not to draw the dash box if no variables are declared within it. Will it throw errors if we use empty type parameters? Yes. I'm going to be a little bit hesitant. I'm like 99% sure that's going to be an error. If on our variable name we have an empty list, if I just delete integer here, that'll throw an error. But if I delete the entire parameter list, including the angle brackets, that will not throw an error until I try to add something to it. And it's going to say you're trying to add an int to an array list that doesn't have a type. That's going to be an error. I'm pretty sure if you just delete integer and leave the empty angle brackets, that'll be an error on your variable type. You declare a loop variable outside the loop? Yep. So if I do int x equals 0 up here before the loop, I can just have absolutely nothing here and just start with a semicolon and have the other two statements. And that's something I'll do sometimes if I do want access to that variable after the loop ends. I'll just declare it before and then not have an empty initialization statement. It's perfectly valid code, and it gives you access to the iteration variable after the loop ends. Glad y'all started using chat. I like this. I know there are questions out there. I'm glad we get to answer them. I do have to get to hash maps, though. What happens if this is empty and new has a type? I'm quite certain that would be an error because it'll say like array list of integer trying to be assigned to an array list with no type. Pretty sure that'll be an error. But my shorter answer is just don't do that. It should, if it's not an error, let me say it this way, if it's not an error, it should be. Java should yell at you for that. But I'm pretty sure it is an actual error. All right. Let's talk about hash maps. I have much less to talk about hash maps, so we should be able to get through this in the short amount of time. It takes a while to talk about arraylist because I'm introducing type parameters, references, heap space. We got auto boxing. There's a lot to talk about with them. With hash map, it's a lot of the same stuff. There's just one new topic we're going to add. So it goes a lot faster. This is our dictionary in Python, our object in JavaScript. It's a key value store. Instead of associating values with indices starting at 0, we're associating values with other values as keys. Just like arraylist, we have to import it. Hashmap and arraylist both live in the java.util package, so import that thing. And then we need two type parameters here. So this is a little different than arraylist, but same concept. We have a comma-separated list of types when we create a variable of type hashmap, because these keys and the values can have different types. They have to be consistent across key value pairs, so all keys have type string in this hash map, and all values have type integer, I guess. But we do have to specify those when we declare a hash map. So this is a hash map of string to integer, or a hash map that maps strings to integers. Are kind of the two ways I like to say that. Usually on a homework, I'll say, write a method that returns a hash map that I almost said it the wrong way. Write a method that returns a hash map of string to integer is usually the way I would word it on a homework doc. We want to add things, add a key value pair, put. Takes 2 arguments, key and value. If we want to get the value at a specific key, .get. I don't have a lot to say about that. It should be pretty familiar. And the new thing that we're going to see is the for each loop. Luckily, this is very similar to Python loops and JavaScript loops, most of what you've seen last time. We have the iteration variable for what it's worth. Every variable in Java has to have a type, so we have to have a type here, is the big difference. And then this is read as in, so for key of type string in something that we can loop over. This is usually a data structure or just anything that can be iterated over. In our cases here, and it's called enhanced loop because Java has to call things different things. And for our hash maps, we can iterate over just the keys or we can iterate over just the values. We do that by accessing either the key set or the values. And a lot of times it's common to iterate over both. I like to do this, iterate over the keys, and then the first line of my loop, I'm going to access the value. There is a way, if you want to look up entry sets and you want to loop like that, go for it. I'm not going to cover that in lecture, though. I prefer to just do this third loop. I think it's a little more clean, and it's one less thing to have to memorize. The syntax of iterating over an entry set, you can iterate over keys and values simultaneously. For my money, it's just not worth it. Hash maps are stored on the heap, just like arrays, just like arraylists. We're going to have only references to our hash maps on the stack. And for this one, just to prove that those numbers are meaningless for the references, I just decided to choose 519 for this one. I whacked my keyboard, and those are the 3 numbers that my hand hit. Well, I whacked it a few times. I can't reach 1 and 9. Yeah, that'd be tough. But put is going to add them. So instead of having indices starting at 0, the first column is going to be the keys. And when we print out a hash map, it's going to be braces, key value pairs separated by commas, key and value separated by equal sign. Again, if you don't memorize the exact syntax there on a quiz, I don't care. This is very similar to JSON syntax, except instead of colons, we have equal signs. And notice that the order doesn't matter. So when I printed this out, when I set up this example, Java printed digs before Allen, even though I inserted Allen first. The order doesn't matter for hash maps. Order will not be preserved for you, so you might get different order. When you're doing your memory diagrams, I don't care what order you iterate over. I don't care what order you print in, because you're not going to know what the order is going to be when you're sitting there with pen and paper drawing your memory diagrams. So whatever order is fine. When I do my iteration, I iterated Allen first and then digs. If I iterate over keys, I just get the keys. Iterate over values, I just get the values. When I iterate over the keys and access the value, I can access key and value simultaneously.